So, in today's video we will learn about the midpoint theorem, which is an important topic for class 9th. So the midpoint theorem says that when D is the midpoint of AB and E is the midpoint of AC, D is the midpoint of AB and E is the midpoint of AC, only then DE is parallel to BC and DE is half of BC. We can also prove this, but we will prove it later. Firstly, we will try to understand what these statements want to say. So, here D is the midpoint of AB and E is the midpoint of AC. That's why DE means line DE will be half of line segment BC. So if DE is equal to 10 centimeter, then BC will be 20 centimeter, and also DE will be parallel to BC when these both are midpoints. Now we will try to understand what is the converse of midpoint theorem. So let's suppose ABC is a triangle, and in this triangle there is a line, let's name it DE, and it is said that DE is parallel to BC. It is given that DE is parallel to BC, and it is also given that DE is half of BC. Like in a question it's given that this is 20 centimeter and this is 10 centimeter. So by using the converse of midpoint theorem, we can easily prove that D is the midpoint of AB and E is the midpoint of AC. This is the converse of this theorem. There are many questions based on both of these theorems, and I can also teach the questions, but I will teach them in later. Now let's take a look at the proof of this theorem, which is generally asked in class 9th pre-boards and boards, and usually it's important for classes 10th, 11th, 12th. Means if you want to take mathematics stream and you love geometry, this theorem is a must. Okay, so to prove this theorem, firstly we have to do some construction. Like we will make a line from here and also make a line which is parallel to AB. Okay, let's give them some names, like name the points. Point F. Okay, so now we can see that we have triangles ADE and triangle CEF. Let's prove them congruent. So in triangle ADE and triangle CEF, here these are vertically opposite angles, so angle 1 is equal to angle 2. Then and now as both these lines are parallel, we can say that these are alternate interior angles. So angle 3 is equal to angle 4. And now we know that E is the midpoint of AC. So AE is equal to CE. So by above points, which is angle, side. So triangle AED is congruent to triangle CEF by AES criteria. Okay, so let's move ahead. Now, as these both triangles are congruent, we can say that ED is equal to CF by CPCT, and as we know that D is also the midpoint of AB, we can say that AD is equal to BD is equal to CF. Now here we can see that AD is equal to CF, and also BD is equal to CF. So we can from this point we can say that BCFD is a parallelogram. Why? Because a pair of opposite sides are equal. That's why we can say that BCFD is a parallelogram. So as we know, in a parallelogram, opposite sides are equal. So BC is equal to DF and BD is equal to CF. Also DF is parallel to BC. Okay. Now E is the midpoint of DF. Why? Because as you can see in the figure, these triangles are congruent. So it means this must be equal to this. That's why we can say that E is the midpoint of this line segment DF, which means that DE is equal to EF. Now I will prove some points like see here. BC is equal to DF. BC is equal to DE plus EF. Now DE and EF are equal, which means that BC is equal to 2DE. Now from this we can say that half of BC is equal to DE. Here we have proved our first point. Now the second point, which is BC is parallel to DE, we can easily prove, because in this figure you can see here that both these are parallel, because we have proved that BCFD is a parallelogram. So it's already proved that BC is parallel to DE. Here we have proved our second point and our theorem is proved. So thanks for watching my video, friends. I will soon more theorems on this channel, and we will also start NCERT exercises. So stay tuned for more updates, and please subscribe, like and comment.